Hello, everybody. This is Professor Ma, and this is the introduction to the sections on hyperbolas and parabolas, more on parabolas. And this is optional because the basic techniques we're going to go through, we already went through for circles and the ellipses. Okay, and we're going to do the same thing for hyperbola. That is going to define what it is. And we're going to then say there's a standard form that can manipulate the equation into a particular format. And from eyeballing the format, we can establish some crucial features on how to construct the graph, basically, anchor some important points. Okay, so here we go. We call the conic section, we got four objects: circles, ellipses, parabola, hyperbola. So we're going to deal with hyperbola now. Okay, and in particular, hyperbolas is when you have, remember, we can, depending on what these two terms are, if these A and B are different signs, one positive, one negative, then I can always divide it by A, and then we become 1x squared. So, we gauge synchronize x squared to be 1. Then the in front of the y squared will be a negative number. I write it as a plus r, where r is a negative number. Okay. In such a case, then these are hyperbolas. Okay. And this is just a bit of reminder how ellipses are elongated circles, and you keep doing that. When you get to r equal to 0, I just get two lines: x squared equal to 1, x equal to plus minus 1. Now, if you get into r negative, then the two lines now start forming the shape of two hyperbolas. Okay, which is what we're going to do now. The r being negative. Okay, what is the geometry of hyperbola? Again, for hyperbola, there are two foci, we call F1, F2, and every point, okay, here are 3 points, random points on this hyperbola, and has the following properties. Okay, I take the distance of a point to the two foci, that I subtract them. In other words, I take the difference of the two distance measurements. Remember, for ellipses is the sum of these two distances. And in hyperbola is the difference of these two distances. What about this difference of these two distances? Well, if I measure from another point B, it's the same difference. If I measure from point C, it's going to be the longer one minus the shorter one. It's going to be the same number. In other words, the difference of the distance to foci is a constant. Okay, that's what the decipher that makes in terms of pictures. And about how a hyperbola has a center, just like all the rest of the except parabola. Just like circle and ellipsis has a center, and it has a pair of lines that the hyperbola that are asymptotically approach. Okay, and so then the basic way we're going to graph hyperbola is, first of course, is identify it is a hyperbola. Then we're going to approach is going to graph basically the two vertices, and we're going to graph these two asymptotes. Then we're just going to sketch these green lines along this asymptote. Assume we have all the asymptotes and the vertices figured out. Then we trace the green line, sideways or up and down. Okay, we're going to tie them all together. Okay, and so basically hyperbola forms, and this is the following procedure we're going to do in drawing it. Okay, First, we're going to draw this box, depends on what the center is. Okay, the box will have our x radius and y radius, A and B, again, in two directions. And we have this rectangular box. Then along the rectangular box, we have these two lines. Okay, and then the depending on which version it is, up and down or sideways, okay, the vertex sits on the waist of this box, or maybe the up and down midpoints. Okay, in this case, it's sits on the waist, so then we trace the green line as a hyperbola. And so this is basically the geometry if you want to kind of see what it looks like. Okay, the important points are the vertices and asymptotes. Okay. And so let's start with equations, and then we extract from the equations and the information about the box. Okay, and how? Oh, we're going to use the equations to maneuver completing the square into one of these forms. Okay, and you say, how do I know which form it is? Well, it depends on which one is positive. If x squared is positive, then this goes in that form. But if the y squared is positive, x negative, that will put into this positive square for the y. So notice in the both form, there's one positive square, one negative square. You have to just match it. Okay, let's put the positive x squared in the front. Okay, and notice in these types, then I have a solution for this equation. If I cross that out, then something x squared over a squared equal to 1, then yeah, I can find some solution for x. Therefore, there are two answers for these equations. Okay, solve for that. In other words, the hyperbolas is going to have vertices at those 2 points. In other words, the hyperbola is going to be formed sideways. But in this, if you attempt to solve for the, say, hey, how about if I cross this out? Well, that's an impossible equation to solve. Therefore, there's no y-intercept. Similar reasoning you can tell, okay, and for this y, it has a y-intercept, hence the hyperbola must goes up and down. Okay, so from here, we can identify what the center is. First of all, HK are center. And the radius for that box is A and B from the center. So you can graph that little box in the middle for the hyperbola. Okay, and it opened in the x directions. Okay, and this open in the y directions. Okay, and here's how we graph it. We'll come back to these. Okay, just do examples. Okay, first, I know it's hyperbola. Okay, how? Because I know there's a positive x squared and one what? Negative x squared. Different sign. Therefore, the graph of this is a hyperbola. Where's the center? 3 minus 1. And x radius is 4, y radius is 2. Okay. And it forms this box. And I can grab the diagonal of this box. It's easy to find out the equation of this box, but we're not going to bother about that. You can read out the slope path to that point. You can plug in a point slope formula, boom, you got the equations. But we're just going to sketch a box, sketch the graph. Since x is positive, x squared is positive, so the two vertices of the parabola sits right here on the waist. Okay, you can figure out what that is. Then move one to the right by 4, one to the left by 4. I got these 2 points, and then we trace the hyperbola. Okay, and now this is how we graph a hyperbola. By again, go to the center, draw the box, draw the diagonal, and we excuse me. And the what was I thinking? Yeah, draw the asymptotes and draw the vertices, and I know which way it goes, and then we trace a hyperbola. Okay, now, how about if I start out with an equation like this, which I can identify it's a hyperbola because these are two different sides. How do we then put it back into that standard format? Completing the square. Okay, so it's the same steps like the ellipse, but you gotta be a little bit careful with the signs of the number we adjust. You take the numbers out, and you take the other group dx, group dy, and you complete the square. Right? Put a 4 in there and put a 1 in there. And then you sit back and say, what exactly you add or subtracted? Well, then 4 and 4 is 16. And subtract -9. So therefore, the number adjustment is 16 minus 9. And this is basically the steps which you have to watch out. For hyperbola, one added numbers, one subtract numbers. Okay. Adjustments for completing the square. Once we pass these steps, then to get the 1, you divide it by 36 and do the appropriate simplifications. Voila, we got into the standard form of the hyperbola. Okay, from here we can draw the center, draw the box that defines the asymptotes. Okay. And since y squared is in the front, so these two up and down center points is the vertices of the hyperbola and the trace hyperbola along the asymptote. And that's it. Okay. And so this is homework. Yeah, part of the homework. About parabola, we did parabola already, okay? And then we go to now, we did the function form of the parabola. Now we're going to take a look at the other ones, that is x in terms of y. And one of the x squared terms is missing. Again, the parabolas, let's go through the about parabola, how to graph a parabolas. This is up and down parabola. We went through all that, and we graph these. Just to remind you how to graph these. We graph the vertices of the parabola, minus b over 2a. That's for the x values. You have to figure out what the y is. So the vertices is 116, and this is a parabola pointing up because it's pointing down. Sorry, this is a negative number. So its vertices as 116. So it goes down. Arch. Okay, and we go to the steps. Okay, this is the we have back in a few sections ago. Now, this is what we are going to graph for missing x squared. Then we can solve for the x term in terms of y. It will be y squared, y something, and the formula are exactly the same, except all the letter and xy are switched. So in particular, if a is positive, then parabola points right. If a is negative, parabola points left. And where is the vertex? It happens at the same formula. Y is equal to minus b over 2. Okay. And you put this number in, and you get the x coordinate to get the position of the vertices. After we did get that, and then we find 2 more points that form the triangles of the tips of the parabola to the left or to the right. Here's an example. Where's the vertex? Minus b over 2a for the letter, for the variable y. So y got to be minus b is 2, a is minus 1. So it says that y is equal to 1. Plugging 1 into for y, then x must be 16. So the vertices, it's going to be a 16, 1. Okay. So want to draw, that's fine. 16.1 on XY coordinates way out here, 16.1. Okay, remember Y, the 1 is for the Y coordinate. Okay, we get that first. Okay. And which way is parabola facing? It's negative Y, so parabola face this way. Okay. And then the rest is kind of easy because these, let's say, let's try to find out what that point is. That's the x-intercept. To get x-intercept, you put y0. In other words, cross this out. X15. Opposite up there, okay, is 15. But height will be, instead of 1, will be now double to 2. So once I get those 3 points, and then I have the tip of the parabola that I can trace a parabola. And then I can solve for the y-intercept, and then this is the completed graph of the parabola sideway. Okay, and that's it. And do the homework. Yeah. Bye bye.